question. So the example question says, and the 14.4 is meaningless. You just need to get down the question as well as the equation. Nothing else below it though. The question as well as the equation. We will solve this problem using those previous 3 steps for titration. But we need to get the question down. What is the molarity of an HCl solution if 10 milliliters is required to titrate 12.54 milliliters of 0.100 molar NaOH? So our first titration example problem. And then we're going to write down that equation. NaOH plus HCl producing NaCl plus H2O. One of the first things that I do when writing down or trying to solve this type of problem is I make a picture of it. Towards the end of the first period, somebody raise your hand and say, Mr. Hyde, I really like that picture. It helps me understand. Me too. Anytime I'm solving these problems, whether I'm getting titration set up for you guys, whatever, I draw a little picture. It just helps me orient what's going on. So here's what I'm going to do. I'm going to draw a picture of a burette. And I'm going to draw a picture of an Erlenmeyer flask. And then I'm going to put down what I have of each. Now, to be honest, if you got these switched, it would be perfectly fine as long as each of the values went with the substance that you were dealing with. So, for instance, NaOH is the substance I know my information about. Well, what do you mean by that, Mr. Hodges? Well, NaOH, they tell me that the volume is 12.54 milliliters, and they tell me that my molarity is 0.100 molar solution. The substance that I know the molarity of and the volume of, I put into the burette. The substance that I'm looking for is my HCl, and the volume of HCl is given to me as 10 milliliters. And my molarity, if you look at the question says, what is the molarity of HCl? So my molarity I'm going to list as a question mark. I don't know what my molarity is. That's the purpose of this titration problem, is to find the molarity of HCl. We're going to go through those 3 steps that we previously wrote down in order to find the molarity of HCl. So the way this would be set up in our lab is we would have a burette. We would have added 0.1 molar solution into the burette. We would have added 10 milliliters of HCl into our Erlenmeyer flask, and we hold the valve and we open it, and it's dropping solution in, it's dropping solution in, it's dropping solution in, and then finally there's a light pink color change that is permanent. It doesn't go away when I swirl the flask, and I just used 12.54 milliliters of my 0.1 molar NaOH to titrate 10 milliliters of HCl. And I want to know what my molarity is of my HCl. So how are we going to go about doing this? We're going to follow these 3 steps. Step 1, instead of putting calculate down, I'm going to put find. And what am I finding? I'm finding the moles of my given reactant. The given reactant is the reactant that is given the volume and the molarity. Notice HCl, you only have the volume. This one you're given the volume and the molarity, so NaOH is my given reactant. So I'm going to find the moles of NaOH. According to our steps, to find the moles of NaOH, I'm supposed to use the molarity equation. So the molarity equation that we learned last time is molarity is equal to the moles divided by the liters. But here's the problem. The molarity equation is set up to find molarity, not moles. But if you look over here, my NaOH, I have volume and I have molarity, so the only thing I don't have is moles. So I'm just going to rearrange this equation. It is the molarity equation. I'm just rearranging it to say moles is equal to molarity times liters. I just move liters from the bottom right to the top left, so molarity times liters equals moles. So now I plug in my molarity, 0.100 molar, and I multiply it. Now you have to be careful. I have to use liters here, it's required. Here it's listed as milliliters. To go from milliliters to liters, I move the decimal place back 3 places. So this is really 0.0125 liters. When I multiply those two together, I'm going to be given the number of moles. So I end up with 0.00125 moles of NaOH. My very first step was supposed to be finding the moles of my given substance. And that's what I just did. My given substance is the one that they give me the molarity and the volume. Find the moles of NaOH. Find the moles of my given substance. Step 2. Find moles. Calculate moles of my second reactant. Well, I already found moles of my given reactant. Now I need to find the moles of my second reactant. And my second reactant is HCl. So I'm going to look for the moles of HCl. According to my bullet points, it says use the mole-to-mole ratio found in the balanced equation. So I'm going to go up here and I'm going to use the mole-to-mole ratio. So I found the moles of NaOH. I list that out as 0.00125 moles NaOH. And I'm going to use the balanced equation to be able to find the moles of HCl. I'm going to use the balanced equation to find the moles of HCl by using a mole-to-mole ratio. What needs to go on the bottom? 1 mole of NaOH, because there's a 1 here for the coefficient. 1 mole NaOH, and what about the top? 1 mole of HCl. That's the mole-to-mole ratio from my balanced equation. So moles of NaOH cross out, and this just becomes 0.00125 moles HCl. My second step I used, if this was a 1-to-2 ratio, we would have had to put it in as a 1-to-2. It's not always a 1-to-1. That's why we have to look at the mole-to-mole ratio from the balanced equation. It just so happens to be a 1-to-1 ratio. Step 3. It looks like on step 3, I'm going to need to find the molarity of that second reactant. So find molarity of HCl. Find the molarity of HCl. What does it say to use?
Molarity equation.
Molarity equation. So, do we have a molarity equation? Molarity equals moles per liter. Now in step 1, we had to rearrange the molarity equation. But in step 3, what are we looking for? Molarity, so do I need to rearrange the equation? I don't. I just need to find the moles of HCl, find the liters of HCl, and put it in. My moles of HCl was from step 2, 0.00125 moles HCl. And now I'm going to divide by the liters. That is given to you in the problem. And what's nice is when you draw the picture, then you can see where it is. So HCl, but I have to use liters. You can't use milliliters. So I go 1, 2, 3. So that is 0.01 liters of my solution. So all of this gives me, when I punch it in on the calculator, 0.125 capital M for molarity of HCl. 3 steps to be able to do a titration. I'm trying to find what the molarity, what the concentration of HCl is, and I went through those 3 steps finding the concentration of HCl.